Hey everyone, this is FixReef, and today we have yet another Apex EB832 up for repair. This one came in with the issue that it just does not power on. So let's try to plug it into power and see what happens. So it's plugged into the outlet, and there are no lights. There is nothing here, no lights here. I am not hearing any fan movements or any relays clicking. So something's going on inside. It could be one of the power supplies. It could be something else. Let's open it up and see what's inside. Okay. All right. Looks fairly clean on the inside. Nothing major. Let's plug it in again. See if we get any LEDs on. All right. So it looks like the 24-volt power supply seems to be working, at least for now. It appears that the 12-volt power supply is not working at all. It also has the classic issue of very low quality capacitors installed in it, so I'm not surprised that that's not working. So this might just be our capacitor repair. However, if this was just the 12-volt power supply, we would have gotten at least some lights over here. The 12-volt power supply affects the relays that switch the 110-volt outlets on and off and so on, but it should not affect the status LED. So there must be something else here that's wrong. I am going to upgrade the 12-volt power supply anyway, but and for this I will have to take the whole unit out anyway. So while we're doing that, we might as well investigate if there is anything else that's wrong with this EB832. There has to be something else because the status LED is not running. So let's keep taking it apart. The good news is that the 24-volt power supply is working. So at least we don't have to worry about higher voltage issues. All right. All right, the EB832 is out of its casing. Let's see. Oh, I think I see something. Hopefully you can see it too. Look at this. Coincidentally, I've been working on another unit that has an issue with this chip as well. So hopefully that video is going to come out at some point soon too. But this is a buck converter that's clearly blown. So this buck converter provides power to Aquabus ports, all of the Aquabus ports on this EB832. It also feeds some of the microcontrollers. So for example, there's a voltage regulator over here that goes from 12 volt to 3.3 volts, and it powers microcontrollers. And microcontrollers control the entire thing and tell it when to turn on or off relays and so on and so forth. So this is actually a fairly critical piece of equipment. All right. So let's take a look at it under the microscope. And we'll likely have to replace at least that component, perhaps something else, but we'll start with this. I'll take a look at this. We can clearly see that this buck converter is blown. Again, so this buck converter is the one that's responsible for converting 24 volt off of the big 24 volt power supply DC into 12 volts. So it goes from 24 to 12 volts. And then these 12 volts are used by Aquabus and use some of the controllers that are on board of EB832. Here you can see that there is a hole. You can see that this is bulged, and you can see that this is actually cracked. Let me see if I can zoom in a little bit. So that you can see the damage a little bit more clearly. Crack, hole, bulge, crack. So this whole unit will have to be replaced. All right, so repeel and replace. What concerns me is that there is one of the pads, one of the traces here is of unknown state right now. Well, it looks like the trace is still there. You see that the solder is all stuck here, so it likely shorted on the inside. It blew up. This likely overheated the spin. So hopefully it didn't take out anything else. We'll remove this chip and we will test a few components around it to make sure that those are still okay. In particular, this little capacitor here is of a concern. I'm going to remove this using my rework station. So we added some flux. Let's now heat it up. We're reaching the melting temperature soon. And it's out. Very good. So let's set it aside for now. Now let's clean the pads and hope that they have not been damaged when the short happens, because this pin came off and the pin is still sitting on the pad and sitting on the trace. So hopefully we're going to be able to get that pin off. All right, this side looks real good and clean. And now we are at our problem pin. Be real careful. I don't want to damage the trace, so that I don't have to repair it. But it might be unavoidable, because when it shorts like this and it burns, it often welds itself to the trace. In this case, it's not that big of a deal, because even if we damage the trace, we can connect it to a nearby components fairly easily. I'm going to add a little bit more solder to this in the hopes that it's going to break it loose. Yeah, I don't think it's going to give in. I really don't think it's going to give in. Our capacitor got moved a little bit, but that's okay. Okay, one last attempt, and if it doesn't work, and it likely will not work, we'll just cut it loose. This was a short to ground, so this is likely a ground pin. Okay, I think I'm done with this. I'm just gonna cut it off. It's not salvageable. Okay, let's clean up and see what kind of damage there is. Again, the good news is that this trace is a part of this very large area, copper area here, so we can connect it to absolutely anything we want, and it will still work. And you can see that there is a bit of a damage to the board from the short as it was burning, but nothing major is damaged, so that's a good thing. Okay. Now that I have the burnt component removed, I'm going to do a quick test on nearby components to ensure that they all work. Okay. No short. This diode is good. Excellent. Looks like we have this diode missing here, so that came off as well. Maybe that was also part of the short, so we'll have to fix this diode as well. Okay, not a big deal. Now I'm going to prepare the site for the new components. I haven't decided yet which way I'm going to connect the missing pin, but we'll figure this out once we get there. All right, nice leaded solder is installed. Now we're going to get the components. All right, let's pick the missing parts. All right, so we are going to need a diode. And we're going to need a buck converter. All right. All right, now that we have the parts, we're going to go ahead and install them. So there is nothing particularly special about this diode, but the buck converter is actually different. It's the same company and it's the same type. However, this is an automotive grade buck converter, meaning that it's going to perform much better under extreme conditions, such as higher temperature. This component costs about twice the cost of the original, but it will actually work better. And since this is a very common issue with EB832s, usually when I work on EB832s and I see issues like this there, I usually upgrade it to a higher quality component like this. All right, actually, let's do it one at a time. I'm going to first solder in the diode. Let's actually add a little bit more flux here. See how the chip is dancing a bit? That's the indication that it's sitting pretty well on the pads. Okay, let it cool off. Make sure that it's stable. Looks solid. All right, a little bit more flux here. And we will solder the buck converter. Okay. Now all we have to do is just connect the remaining pin to the trace, or straight to this capacitor over here. All right, so we'll need a thick enough wire. Let's see if this is going to be thick. This might be not thick enough. Yeah, we'll need something a little bit bigger. Let's see if this wire is good enough. Oh yeah, this will work. All right, we'll need some leaded solder on the remaining pin. And a little bit more on the capacitor. That looks good. And a little bit more flux. And this will hold. this is going to be good. All right, let's clean everything up. I'm going to move the copper wire, the jumper wire down closer towards the board. I don't like it hanging up in the air like this. Okay, that's perfect. Now this is perfect. Let's remove excess solder. Now this looks really good. All right, some final cleanup. While it's drying, I'm going to apply some solder mask to protect exposed copper from oxidizing. I've done this in my previous repairs before. This is a very good approach to not only protect the area from oxidizing, but also to help kind of hold the trace in place and hold that jumper wire in place. I'm just waiting for alcohol to evaporate for the most part. Actually, while we're waiting, we might as well clean it up a little bit more with the brush so that any residue that was left will be absorbed by the tissue. Okay, now this looks really, really clean. All right, now let's apply some mask. Again, I've done this in my previous repairs. You don't really need a whole lot of it, just enough to cover the trace, to cover the jumper wire, so that it is touching the board. As it hardens, it's going to hold on to the board and not let it come off. Remove excess. And let's harden it with some UV light. We'll let it harden for a few minutes and we'll come back. All right, done curing the mask. It looks nice and solid. Nothing's moving. Everything's connected pretty well. All right, so I think we're done with this circuitry for now. Let's find out if that solved our problem. All right, so I reattached the front panel to this. Let's see if it powers on and it lights up if we plug it in. Remember that at this point, the 12-volt power supply over on this side is still broken, likely, so not everything is going to work. Okay, look at that. We have a flashing Neptune sign. So that means that the power to this unit is restored. At this point, I'm going to upgrade the 12-volt power supply, and we'll see if the whole unit works. If you want to know how to upgrade the 12-volt power supply, watch my other video about specifically that problem of proper EB832 repair of the 12-volt power supply, where I replace all of the capacitors on that small 12-volt power supply that's on the right side of the unit. Okay, so I've upgraded the 12-volt power supply. I've attached the front panel to it. Now let's see if it works. I'm hearing clicks of relays. Relays clicking means that the 12-volt power supply is actually working. Let's take a look. I see the red LED. Excellent. I see that red LED inside the 12-volt power supply. The 24-volt power supply has the LED, the green LED on. Right in here. Let's look at the front panel. The front panel is blinking. So while I was talking, these LEDs also came on because it switched from trying to connect to Apex into the fallback mode. So these status LEDs are also on. So at this point, this EB832 is now fixed. Now that the unit is completely assembled, since I've been working on the 12-volt buck converter on this that provides power to all of the Aquabus ports on this unit, I'm going to test the output of this 12-volt Aquabus by putting a load, by applying a load to the Aquabus port and make sure that it can handle a typical load that this unit should expect. Currently, it looks like the buck converter is doing its job. The main LED indicator is on. All of the outlets seem to be working. Now let's make sure that it can handle the usual 450 milliamp load on those ports. Again, we're looking for any drops either in voltage or in current at any point in time. If for a couple of minutes we do not see any issues, likely the repair is complete and the unit is functional. Again, I try to do this on all of my DC outlet related repairs, because just by replacing a buck converter or any other component, or for that matter the 12-volt power supply that's here, I do not yet know if that was the only problem. I need to make sure that the entire circuit that provides power to that 12-volt or the 24-volt outlet is going to work under proper load, and that's why I have an electronic load tester here. Looks like it's handling the load quite well, so I believe that this completes this repair. What was done to this EB832 is we've fixed the buck converter that converts 24 volts to 12 volts specifically to power Aquabus outlets. This 12 volts is different than the 12-volt power supply that's here. So this buck converter was blown. Not only did we replace this buck converter, but we also upgraded it to an automotive quality buck converter that's supposed to work much more reliably, last longer, because it's an automotive quality buck converter. It costs about twice the original buck converter that was installed here, and it's supposed to last longer. In addition to replacing and upgrading the buck converter, we also upgraded the 12-volt power supply. The 12-volt power supply was also blown, so we had to upgrade that with capacitors that will last much longer than the cheap components that are installed in there originally. We've tested the entire setup under load. It's capable of providing the expected output for an extended period of time. Everything works good, and this EB832 is ready to be put back in service. Thanks for watching. If you like this video, please like and subscribe, and we'll see you next time.